14 carats, I'm 14 carat. Doing it up like Midas. You say I got a touch, so good.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now we move on to talking about measuring heat transfer. So the heat required to raise the temperature of an object by 1 degree Celsius is the heat capacity. So let me repeat that again. The heat required to raise the temperature of an object by just 1 degree Celsius. So for example, 98 kilojoules of heat, or Q, is required to raise the temperature of ethanol by 2 degrees Celsius. So by adding 98 kilojoules of heat, it increases the temperature of ethanol by 2 degrees Celsius. This means that the heat capacity for ethanol is going to be 98 kilojoules divided by 2, right? Because you want to know what it is to raise the temperature by 1 degrees. And we end up with 49 kilojoules per degree Celsius. And this is the unit for heat capacity. Since the heat required depends on the amount of substance, heat capacity is known as an extensive property. And an extensive property is when it depends on the amount of substance. So really briefly here, an intensive property, on the other hand, does not rely on the amount of what you have. And I put this diagram right here because I think it's really important to differentiate between heat and temperature. When we're just going about our daily lives, it's really easy for us to confuse feeling heat with the temperature. But the heat, in the terms of thermodynamics, is the total internal energy that's added together in a system, whereas the temperature is reflective of the average kinetic energy of a molecule. So these are completely different terms. Okay, so now moving on, if we divide the heat capacity by the amount of substance that is present, or grams, since remember it depends on the amount, then we have an intensive property called specific heat capacity. So now, since we're dividing it by the amount present, we have a unit of kilojoules per degree Celsius per gram. Also can be written as kilojoules, degrees Celsius -1, gram -1. So the specific heat capacity is the heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So now that we divided it by a mass amount, we converted it to an intensive property. We can also talk about molar heat capacity, which has the units kilojoules per degree Celsius per mole. More often it's written as joules per Kelvin mole, where Kelvin, remember, is degrees Celsius plus 273. That's just a conversion. So the molar heat capacity represents the heat required to raise the temperature of 1 mole of a substance by 1 degree Celsius. So now from here, I wanted to tell you guys the molar heat capacity of a gas at constant volume is given the term CV. So this is the molar heat capacity and I'm going to just use C as representative of heat capacity of a gas at constant volume. So I introduced this a little before, but when you see this little v after the term, it means it's at a constant blah blah blah. So in this case, at a constant volume. So the molar heat capacity of a gas at constant pressure, you can guess, is going to be Cp. And this is the molar heat capacity of a gas at constant pressure. So then when you heat a gas at constant pressure, then the heat required for that to occur is delta H, which can also be written as NCP delta T. So now let me walk you through this. Remember, Q represents heat, and this little p says this is the heat at constant pressure. I mentioned this when I first started talking about thermodynamics, but when heat is at a constant pressure, this represents the enthalpy or the change in enthalpy of the system. This can also be written as NCP delta T, where N is the number of moles, Cp I have right here is the molar heat capacity of gas at a constant pressure, and finally delta T is a change in temperature. So if you look at the units, you have moles multiplied by the molar heat capacity of gas at constant pressure, which is going to be in joules per degree Celsius mole. And then let's say temperature is given in degrees Celsius. You can cancel out units and end up with just joules, which is the unit for energy. So specific heat capacity is often called specific heat and is measured using a calorimeter. So this is the instrument that measures specific heat, which I'm going to give the value Q.